In this video, we are going to talk about lines in context, so word problems where you might be able to apply y equals mx plus b. So to do that, we're just going to go through some different examples of some types of word problems you might run into. So first of all, let's talk about scooter rentals here in Portland. My husband works for the Transportation Bureau, and so he does this exact thing. So renting a scooter costs $1 to unlock, and then 15 cents per minute after that. You might be asked to write a rule and define your variables. So what's your independent variable, what's your dependent variable, what's your input, what's your output, and where do those numbers play in. Take a moment, see if you can take a wild guess, and then we'll talk about it. All right, so as far as variables go, I see two things happening here. I see the costs, and I see the minutes. So one of those is the input and one of those is the output. Well, you don't say, I'm going to go spend $15 on scooters today. You say, I'm going to go ride somewhere, we'll see how long it takes, and that's going to tell me the cost, right? So that means that minutes is my input, or the X, and the cost is the output, or the Y, okay? And then I know that it costs $1 to unlock, and it's going to cost 15 cents per minute. So I could start by kind of making a table to help me think myself through this. And let's say I spend 0 minutes, but I unlocked the scooter. That would be $1. And then after 1 minute, then it'd be $1.15. After 2 minutes, it'd be $1.30. Hopefully that helps us process through what's happening here, right? We're growing by plus 15 cents each time, and our starting value is 1. So our rule would be y equals 0.15x plus 1, where, and then we can label each piece. So y is the cost in dollars, x is the time in minutes, and our growth here is 0.15, right? That's our slope, and that represents the cost per minute. And the, oh, no, I'm not out of colors, we're good. It'll be a sad day when I'm out of colors. And the plus 1 is the starting cost. Ooh, cost. How about that? All right, let's try another problem. Actually, just kidding. Let's continue with this one for a minute. So let's say there was a follow-up question. So there's a couple different way questions like this could be phrased, but let's take two common ones. So use your rule to see how much a 7-minute scooter ride would cost. Well, minutes, we already decided, that's our time, right? So you want to define that this is our x. So we're trying to solve for when x equals 7. So we take our rule, y equals 0.15 times 7 plus 1. You do that math. I got 1.05 plus 1, which would be 2.05. So the ride would cost $2.05 for 7 minutes. It's pretty cheap. 7 minutes isn't very long though. Okay. And then the other way we could ask this would be that kind of silly way I first said that doesn't make quite as much sense, but in theory, if you had exactly $20 to go for a joyride, how long could you ride for? So this time, I'm giving you the output, right? So I'm telling you y equals 20. So you're going to do 20 equals, and then the rest of the rule, 0.15 x plus 1, and then you solve for x. Take a minute and do that now. I moved mine over here so that I could actually write it out, so I subtract 1 from both sides. I divide by 0.15. I'm going to use a calculator for that. I know I made you do it by hand in 6th grade, but I think we're okay using calculators for that sort of stuff these days. And so that gives me 126.67 rounded. And this is money, so it makes sense to always round to the hundredth, would equal X. So I could ride for, they'd probably cut me off at 126, though they don't usually give you the extra. So I'd ride for about 126 minutes. Okay, another way you might need to apply y equals mx plus b in context would be if I give you a graph and then asked you to interpret different features about it. So I've got a line here. I haven't given you much information. I've just told you that the x represents months and the y represents money owed. So pause for a minute, take a look at this graph, and what could the context here be? I want you to make up a context. And then I want you to think, what does the slope represent in that context? Give it a shot. So maybe you thought that this represents someone borrowing money from a friend. In that case, they would have borrowed $70 because that's what happened at month 0. And then the amount is slowly going down. So that means they're paying it off consistently, right? So they're paying back $5 per month. We know that because after 4 months, they're only at $50. So at 2 months, they're at 60, so they've paid off $10 in 2 months, so then in 1 month they've paid off $5. Now, questions like this will often ask you something that's not immediately visible on the graph, so they might say, what does the x-intercept represent? And when is it? So in this case, the x-intercept is going to represent when the money's all paid off, right? And to find it, we're going to need to combine some skills from last time. So you're going to need to have a rule for this. So we know we're doing y equals mx plus b. They've already told us that our x is months, our y is money owed. We borrowed $70 from our friend. That's our starting value. That's B. And we're paying back $5 a month, so that's M. So our rule would be y equals, except we're paying back $5 a month. So our M is going to be -5, because it's going down, right? So -5x plus 70 is going to be our rule. And then they want to know when the x-intercept is. Well, that's going to be when y equals 0 is our x-intercept. So we're going to plug in 0 for y and solve. And divide by -5. And we'll see how many times that goes in. Must go in 10 times into 50. So then there's an extra 20, so that would be 4. So I'm going to say after 14 months later. That is a long time to be paying something off. Oops, sorry, you guys couldn't see that. 14 months until the debt is paid off. Always, when you have a word problem, always make sure to give your answer in a complete sentence so that the context makes sense. The big picture idea here, of course, is that M, in situations like this, M is always going to be your rate of change. It's going to be a rate of some sort. The M is representing how something is changing over time. Okay, I'm going to go ahead and give you guys a practice problem now. It's going to be a little bit different from the two that we've already done. but we'll talk about it in class together on Monday or Tuesday, whenever I see you next, okay? So give it your best shot. If you need to make a table or a graph in order to figure out, you can do that. All right, so your problem is, I filled up a kiddie pool for my kids, but it has a leak. After 3 days, it has 35 gallons in it. I know this because I'm a genius. After 10 days, it is completely empty. We're going to assume that my leak is consistent, that it's draining at a consistent rate. I want to know, how fast is it leaking? Okay? So figure that out. Try and apply your linear equations work to do this. I'm not asking you to find the complete rule. I just need to find how fast it is leaking. Give it a shot. Enter it in on your submission box.